Hey, everybody. Good morning. Good evening.
Hello.
Mel.
Hey, it's Simon.
It is. I turned up this.
Welcome. Yeah, you're here today. Great. And Mark is here today too. Excellent.
Hi.
Hey, Mark. I'm going to wait another couple minutes.
Mohammed, Simon, thank you both for commenting on the Attestation Governance Patterns doc. I look forward to working with you on making it better.
That's a you just volunteered yourself, thank you statement, I think. But nicely done there, Mark.
Yeah, I'm happy to do that.
It's an important part of the job.
That's right.
Does somebody have a link to the agenda doc? It's not as high up in my most recently used documents as it normally is.
I put it in the chat.
Could you put it in again? The problem is that you don't see chat messages from before you joined.
Okay.
Well, I don't. Maybe other people do, but it's thanks, folks.
Thank you. No, that's right. Once you join, you don't get the historical messages.
Yeah, or the hysterical ones, possibly.
All right. Looks like we've got a good group of people here. Good quorum. So let's get today's meeting going. So today we officially have two topics on the agenda. One is Simon discussing the collection proposal that he's put out there, and the other is Mark Novak talking about the Attestation Governance Patterns document that he has shared recently. So the ordering is Simon first and Mark second. But before we jump off in there, is there anything anybody wanted to briefly insert here at the beginning?
Yeah, so I'd like to introduce Jim. We've got time for that.
Yeah, I think we do.
Great. So let me just double check. I don't see Sean Way on today. Is Sean Way's last day at Intel. He is retiring, so I wanted to thank Sean Way, even though he's not here, for his many contributions in the attestation SIG, including helping try to bring the RATLS implementations together. Sean Way's presence here is going to be replaced by Jim Beanie. Jim leads our data center attestations primitive projects, as well as a number of other attestation topics at Intel. So he's going to be a great addition to this crew here. So he is replacing Sean Way.
Yep. Well, pass along our congratulations to Sean Way, and welcome, Jim.
Thank you.
Yes, same here. Jim, anything you briefly want to share with folks? Introduce yourself, or was Dan sufficient?
Yeah, I think that's sufficient. I know a few people here and familiar with the names. I've been working on DCAP since the beginning with the introduction of Ice Lake Server, SGX and Ice Lake Server. So I've been working on the project for a while, and still, we're working on, our future products and the support for attestation. We'll have an SGX and TDX, as well as our effort to align with the standards.
Cool, excellent. Well, happy you're here, Jim.
Yeah, thanks. Yeah, I work closely with Sean Way and Ned, who's here. So I'm familiar with the work that Sean Way was doing here at Intel.
Okay, great. Okay, so on to the agenda. Simon, are you ready to talk about EAT collections?
You're not, because you're muted, Simon.
Well, I'm ready, but not as ready as everyone else is to hear it. Hang on a second. Okay. Let me know, is that the right screen or the wrong one?
Wrong one.
Define right. It says EAT, correct. Should we also see your next slide's screen
Yeah,
up there as well?
Is it the presenter view? Oh, now this is clever because the Zoom control bar has moved over. Hang on. There's just going to swap these round. Is that you now have the guest view, not the presenter?
Yes.
Yes, perfect.
Right. So I think, yeah. There's a very simple way of doing this, which the Zoom toolbar had overlaid.
Of course.
So EAT collections. What's that all about? So, oh, come on. Okay. So background. I've done doing work for ARM in the confidential architecture and PSA, where we have produced have attestation support. And we have been closely following, engaged with, contributing to the IETF RATS working group. Big fans of the work that has gone on there, and so we have been trying to embrace EAT for that, for the work there. We have the PSA profile contributed as a draft document there, which is help pushing the profile concept on stuff like that. So we're looking to see how this would work for CCA, and no, not that problem. So the background or the fact about EAT, the scenario about the thing about EAT is that the token, the token, it has the EAT has support for structured tokens. So you can have submods, you can have bundled data and constructed data, which includes claims which are validated by a main token. But there is always a top level token in EAT, and that is it's a CWT or JWT. The rest of the conversation I'm just going to be talking about Siebel, so everything is about Jason is assumed, but they do that. And the assumption in those EAT tokens is that there is a top level signer.
Excuse me, Simon?
Yes.
Would you prefer questions on the fly or folks to raise their hands?
On the fly, that's fine.
I've got an immediate one. What led you to the belief that there must always be a top level token? For example, one of the patterns we considered at Microsoft was to, and this was about 3 years ago when we were looking at this, so maybe the world has changed, but we formed the opinion that it was acceptable to have essentially no top level claims except submods, and then have a bunch of children that are, I think, probably going to be conceptually identical to what you're calling an EAT collection. So right. Is that, yeah.
Yeah, well, because the answer to that was when I was doing CDDL for CCA, I'll talk about CCA in a minute and how this goes, things like that. There is now a very good CDDL for EAT, and the top level is a CWT or a JWT or a DEB, but a DEB has to be a CWT for things like that, and therefore you must have that you need that cozy signing at the top.
So is that just because of the definition of the data structures, or was that an intentional choice?
It was. I believe it was an intentional choice because it reflects. It reflects the fact that you need to tie back to a root trust, and that's there now. There was a use case discussed in the working group, which is the unprotected claim sets, the UCCS. which is specifically intended for, say, you have a bunch of claims and you're only transferring them in a secure environment. So that is actually, essentially said, oh, I'm going to stick everything in a map. And that was embraced at top level EAT, but there was a decision taken in the working group to say, okay, we're going to fold EAT out of, UCCS out of the main EAT work in the interest of getting EAT published or moved from draft to standard. So what becomes EAT has become greatly simplified. Sorry, was there a question?
That was very helpful. Does that mean the definition now explicitly states that, even if it was sort of retconned?
Well, there's an explicit. So the definition today is CWT DEB detached bundles, but they are extensible. So it says that you can now extend it because there's this like that. So UCCS is now an extension to the top level token, but not part of the core EAT specification. And that's where we're going with collections in a minute.
Can we mute whoever that is? That's VJ.
We have a separate conversation bleeding over.
Yeah, could someone mute the DJ if they have power to do so?
Oops.
I think you could.
Yeah.
Thanks for that.
Yeah. Okay. So to recap that, so if you have just EAT, then you have a CWT type structure, but you can extend it. The only draft that existed for a non-signer entity was UCCS, which is if you read it carefully, is very constrained. It is very constrained to a particular secured transport entity. So the problem I had is CCA Attestation is formed from two tokens which are bound together. We call that the platform piece and the realm piece. And it's fine, we do this, but then it came to say, well, how are we saying we package these as a single entity? Where someone's making an attestation request, we didn't want them to have to handle these things separately, because you always needed the combination. So I needed a messaging structure that was there. Now I could have potentially done this using EAT and using a submod structure, but actually one of the joys of one of the interesting parts of sort of doing this stuff wrong is we have to consider many different use cases and different things. So there are two signing models which were embraced in, and this is all referenced in the reference work. Implementations can extend it. That's another joy of the art stuff. We had a direct one, which is we were doing everything based off a hardware root of trust, where the attestation secrets lie and signing can happen. So there's two models that support it. Either the whole set of claims will be signed inside the ROT, or for cases where you need high volume, then there's another model which is delegated, which is to say that the hardware ROT signs a platform token which includes a key, so it effectively does key attestation for a key that can then sign the whole report. And those two things get bound together, and the platform token can get cached. Now, if you try and model those two with pure EAT, then there are nice ways of doing that. You can either say that the direct model is the realm claims are just a claim set, and that is the attached bundle, which is then passed to the platform token and signed together. But for delegated, the signer you have available is different. The signer you have available is the realm set CWT. And so you actually end up, if you're, again, trying to be pure, you end up with something that looks very, very different. So the actual difference in if you look at the two tokens is very tiny. There's just one claim difference and the details of how you validate that claim between the tokens are different, but everything else is the same. But, oh, hang on. The pictures you end up with are very different. So your direct in your direct model, you have a single signature, and your leading thing, if you like, for the direct bundle looks like that. But in your delegated model, you have to invert it because of the signee you have available, and that's not very desirable. You want to keep a body of code that's around for validating this that's similar. And it also means that we have considered the possibility of other tokens coming into the mix for trusted entities and stuff like that. So also contemplating how this might apply to other architectures, and not saying I want to directly do certificate chains, but if you look at certificate chains and things like dice, if you were looking to take that information and recast it into an EAT-like structure, you get exactly the same problem. So theoretically, you get a bunch of submods, but actually, depending on what's there. So if you take how you do submods and to do a certificate chain or things of that nature, then you end up with structures like this. But again, it depends on where your signer is. And for example, as we've seen with the classic static model of certificate chains, you don't always deliver the whole bundle. You might want to have your root certificate delivered out of band, in which case your signer changes and your structure changes for that. I'm not saying
I noticed Mohammed has his hand up.
The problem went beyond EAT. Sorry, this question.
Mohammed has his hand up and has
I'm
had
sorry.
it up for a while.
Masana, how can you?
Yeah, Simon, I had a question regarding a couple of slides back. You were mentioning the couple of sets, so platform evidence and the REM evidence. And there you were mentioning something about the set represented as one. And my question is specifically about whether the order matters, in which I understand that both are separately signed, and then one could send in any order, but is there any specific order in which it's sent? How would the verifier know which one is which?
Well, that was the point. I didn't want to send them separately. I wanted to say, here is a token with with all the parts together, and for any implementation, and that could be if say future tokens were there. I wanted a transport, conveyance, and encoding where there was a one-stop shop, and it would be quite clear from looking at that what would be there, which piece was which. So originally it was like, oh well, we can just concatenate, and it's like, actually, well, that's not very good. It's not very nice for the verifier to be able to pull them apart, and that's always been something I've always felt about things like protocols which use search chains. You just get a blob of everything concatenated together. It'd be nicer to have a structure, and that's what I was looking for. And in theory, it will do that with submods, except that, as I'm saying, that we're not flexible in the way I was after.
So just to summarize, you were saying that basically that's flexible. So the format is flexible to whatever you put first or whatever you put second. Is that correct?
Yes, provided you have a way of understanding, understanding what an ordering is, and that's why. And I didn't. There wasn't a way of conveying that that structure.
Okay, so I could potentially put the platform attester evidence first or the realm attester evidence first.
So this is what he's trying to avoid, right?
That's what I'm trying to avoid. I'm trying to say it doesn't matter what order it is, but I will give you something that will tell you what it is. Hopefully, I'll answer that in just a second.
Okay, sure.
Okay, so yeah, so it was worth, the reason it was worth doing this as not just as something something for ARM or something for CCA was because I figured that actually this problem was wider. So the EAT collections proposal, which is a draft written up for the RATS working group, says that when your attestation is composed of related independent tokens, or potentially even just an unsigned claim set, and that the integrity between those tokens is available, it's essentially this way, is then you have a new extension to the top level called the collection, which is essentially a map identifying the elements and therefore solving the assignment problem of what order that they can be in. Potentially, you can have a profile claim related to the v-field claim, which talks about exactly what's in there. But alternatively, you may just be able to do that with a map piece. So this is it's very simple in many faces. So my wrapper, my message structure for CCA now looks like this. So we have a label and then 2 map entries, which I can identify as the specific one. There are points for anyone who can work out why I use 44234. If you wanted to go back to my original question, it's like, oh, how would I change a direct model to a delegated model? I would just swap the label and put a different entry in the map.
So swap what label exactly?
Sorry, so there is a label. So this is a map. So the 44234 is the label. So if I wanted to swap the realm delegated token for the realm direct token, I would change to a different label, which my profile says is a direct token.
Okay, so 44242 is a magic number which you've just told us what it is, right?
It's a magic number that which all of these are on their way to IANA, so they will be they will all be in the CWT register.
Good. I wasn't sure quite how magic the numbers were and when they would stop being quite so magic. That's fine.
They can be found in documentation.
Lovely, thank you. That's a start.
They can be found in documentation. They are on their way to IANA, and they will form part of the CWT structure.
Lovely.
I chose the range because 44234 is hex A CCA.
Nice.
Quite advertising.
I think you may have already explained this, but there's no signer over those 2 elements.
Correct. Deliberate. There is no signer over this.
Yeah,
Okay.
yeah.
Thank you.
So does that mean that this construct is not an ETH token itself, since there's no signer over it? It is designed to be an extension to the ETH token in the way that UCCS is an extension to the ETH token. So it obeys all of the ETH rules, and it works to extend the ETH top level. But I thought somewhere in this discussion there was a statement that ETH has to be signed, and
the ETH top level has to be a CWT or a JWT,
which is
or an extension to that. You are allowed to extend the top level, but ETH
and extend it in such a way that you break the premise of the. I mean,
it doesn't break the premise. Okay. It has to stand by itself in terms of the.
Then I don't understand why submods couldn't be used instead of this new top level claim name, because this looks like it's a submods is just a map, and this is a map, and you're saying this.
No, but submods can only exist inside a signer. So
submods is a top level claim
thing that submods in, because submods only exist in an ETH.
Yeah, and this exists in an ETH, and we just said
no. This exists instead of the CWT top level. It means I can have this is how to define a map at the top level.
Oh, you're redefining the envelope for ETH.
Yes,
you're taking
exactly.
the guts of ETH and you're saying the envelope is different, and that's I wasn't aware that was ETH compliant. To mess with the envelope
in this way that says I extend to a draft.
Okay, so why wasn't then the thinking of, okay, we the problem here ultimately is solved if we can get rid of the signer at the top level. So one step is let's get rid of the signers at the top level and say we're going to use a different envelope that doesn't have a signer. And oh look, ETH already has something that's a map of child claim sets. It's called submods. So you may disagree with the name, but once we remove it, it doesn't I see the requirement to remove the signer in the envelope. I'm not seeing the requirement to change the name of the top level claim that represents this map of, child
Because
claims,
if
child
if I'm
tokens.
trying to follow the EAT CDDL, I can't have a submod. I can't do this and say I've got a label and it's a submod. Because that the way the EAT is defined, the EAT stuff that CDL is defined is that submod must live inside CWT.
So as I understand it, you have two options. You can either redefine the whole what an EAT looks like, or you can use the extension option with a draft, which is what you're doing. So you stick within the existing specification and extend it, which is what you're doing, rather than
that's my intent.
Defining the entire entire definition.
Yeah. And we can follow up offline, or I can read something if you point me to it. I'm not following what is, since submods doesn't apply, and I'm not following then what from EAT does apply when you say I'm replacing the EAT envelope with my own envelope that doesn't require signing. And none of the, well, at least submods doesn't apparently applicable in this circumstance. So now I'm lost as to what else from EAT isn't applicable. So let's not take any more time here.
Inside these tokens, these are both CWTs. So these everything inside there follows the the EAT grammars all the way down. It's just that,
like I said, it's probably me. I'm just missing something, and if you point me to something to read, perhaps.
I could take you through it. Happy to do so. Ned, sorry, you have your hand raised.
Yeah, a couple of questions. So first of all, just so we're on the same page, this is used in the context of the evidence flow and according to the RATS architecture.
Yes.
Okay. And then there's also some work being done to define a conceptual message wrapper, CMW, which I'm sure you're familiar with. Can you say how that relates to this work? Because it's sort of, CMW is sort of a wrapper around tokens in a sense already.
I think CMS is, I don't know. I could follow up on that one. I believe the CMW guys were talking about using collections as their I think if I remember right, the CMW stuff might even be a use of collections with a defined structure in them.
Yeah, my last recollection was that the CMW content was a singleton structure, although it was sort of ambiguous as to what that is. But there was a thread around what if I have multiple message types, and the use case was more in the context of maybe I have some evidence and some endorsements, or some endorsements and some attestation results or whatever, and so the thread seemed to end with, well, somebody could just put an array of CMWs and that would solve it. But so this starts to feel like, the collection starts to feel like it's an array of something. This is being used as a map structure, but you can be flexible with the way that you pick your code points and sort of give it compose whatever you want.
Yeah,
so it seems like it's going in that direction. So I'm just wondering if these things ought to be, just conceptually, does it make sense to try to align them around the idea of a CMW as a sort of a reinvention of a CMW in a different way? What are your thoughts?
I would need to revisit CMW. I haven't looked at it in a while.
Okay.
So I apologize for that. Okay. So now looking at the pictures. So the picture we had earlier is my two structures, which would look very different depending on how they were composed. But actually, in the collection, they are just put together in a transport. Collections have the potential to be one-to-one. Potentially, they could be one-to-n as well. In terms of the inter-element binding, which is the key there.
Simon,
yes,
a question. So again, this may give away the fact that I don't really know the subject matter as well as I might. Are there situations where you might have binding at different levels. So if you had an M to N and you had another thing which actually mapped to a different level rather than to the direction at the top, is that a sensible thing that you might want to be doing to make claims?
You can do. It has that potential.
I assume so. It doesn't have to be entirely linear. You can.
No, that's why I put that little thing in the corner just to show that because this
multiple
this
branches and multiple trees.
Yeah, this is the other picture which shows that, and I suddenly thought, oh, hang on, so everything looks linear.
Yeah. So for instance, if I had something a yellow box that I wanted to talk to the grey box and a purple box that I want to talk to the green box, I could have all of those at different levels as well, right?
Potentially, I mean, it's the same way that you would structure things, as I say, with submods. I'm not anti-submod. I'm not anti-submod. So it's just
no, fine. So you can have
if you have the relationships, you can express them.
Perfect.
Together,
that's the only question I wanted to check. I assumed so, but I wanted to check that it wasn't excluded.
Yeah.
Thank you.
Yeah. So the important bit is security. So this will only work. This packaging mechanism only works if there is an integrity mechanism between all pieces. So each piece needs its own, if it's a token or something, it needs its own integrity. And then there is an integrity mechanism which is, definitely custom between two to bind between the two. So there'll be a claim in, usually a claim in one, which can be found in a signed entity somewhere else. And your verifier must process all of the elements, individually and say they're good, and then, collectively down to things to the profile. Now, to assist that, there is a binder claim, which is specified in the collections draft. And that says that in a member token, you can have a collection binder, which essentially says, take some of my evidence, hash it together or run an algorithm over it, usually a hash, and then you will find it in another element in another claim. So you have a set of source labels, source claims within the collection, and that's usually one, can be multiple. It can be the whole collection, the whole collection element. And it says when you go, you will find the binding for that in another token. So graphically, these two guys here, so that this token here has a claim 999, which has a value, and this other claim, which is probably is assigned, has claim 10, which will have the same value. And your verifier will be going through and checking that the binding between those two is the same. And your binder claim could say that, oh yeah, what I'm going to do is I'm going to take 999, run it through SHA 256, and I'll find it in element 0, claim 10.
So this allows you to make contextual trust relationship.
Yeah, that helps drive this whole. This is how you find the binding. It's only intended as a hint. Again, of course, you need to make sure that your verifier can do this by itself if necessary. But it just helps that drive the collection relationships together.
Nice.
Status. In the interest of time, I've gone on too long. There's been 3 drafts of this, mostly talking about introduce the binder, introduce some of the use cases, submitted the absolutely working group stuff. Some people say yes, I must use this, and so the rest of it, other reviews. Other people are still trying to get heads around it, as I think we found today. So there has been modest support for working group adoption, but I need to go back and see if there is more. And I'm very, very interested in any further feedback or tweaks or criticism. It has proved useful in our thinking, but back to each of them. Ned, you have your hand up.
Yeah, so this is aligned with Kathleen Moriarty's collections work. Is that what you're referring to, or is this different?
I'm not familiar with Kathleen's collections work.
She submitted a draft a while ago. I think she was calling them attestation sets, but it's sort of a collection of stuff. So, but maybe,
Yes,
yeah,
I did read. I can't recall. I did recall that I did read the set stuff, and there was not an overlap, but I can't remember why.
okay.
I'll go back and read it.
So
Yeah, Geshe, go ahead.
I just wanted to just run through with Ned your question about the CMW. So CMW is essentially like helps you identify at the top level what is inside the bag, so that the middle entity can just funnel the message without having to unpack it what it is. That's what, but this is more like a collection of evidence. This is a collection tool. So I think the purposes are slightly different in my view for what Simon is
Yeah,
proposing.
so there was a
what
thread. There was a thread that said, well, what if I want to have multiple messages? And the answer sort of was, well, somebody could define an array of CMWs.
Yeah.
But if you have the ability to have an array of CMWs where the CMW is assumed to be a singleton, but now you can have an array of them, it seems pretty clear that you could have an array of the same type of message. So I could have multiple evidence components in the array, and if those evidence components are both EAT tokens, then I essentially have I could have a token for you could have a token for each of the token types that were defined for this use case. So it seems like it's eminently doable.
But think that the CMW wraps internal evidence as if it should be independent from other CMW instance. So because the purpose is different, now you're saying you want to put two CMWs next to each other. So where is the cryptographic linkage and how do you bind that? Those kind of stuff will come in there, right?
Sure. I mean, those are topics that that would have to be addressed, but at a high level, it's basically a map or an array or whatever. It's a collection of data structures that have to do with attestation, and so
okay.
It seems like we could end up with multiple ways of accomplishing the same thing. And security issues aside, in either case, if you're going to create a bundle of something, you want it to be cryptographically correct. So
yeah, it would be interesting to see where this discussion is going and be part of it. Yeah, thank you.
Cool. Any other questions? You can reach me as simon.frost@arm.com if you want to query anything. Go look at the collection draft. The email's on there. All right, thank you very much.
Yeah, thank you very much, Simon. This was definitely enlightening and gives me many things to think about. If just one request from me, if possible, if you have paged into your head, could you possibly add some links to some of the other docs that we discussed before you upload the deck, just so I certainly would benefit from that, because I probably want to look at your doc and look at some of the other docs and that were mentioned today to kind of wrap my head more around this stuff. So
I think I've got them already, but I will check. Yeah. I think they're already in the notes, but I'll check.
Yeah, the one about attestation sets or something. But
the attestation sets I will have to go look at. Yeah, I've got EAT and UCCS and collection, and I'll look at sets.
Yeah, just if it's easy. I don't want to cause work for you if it's cool.
No,
well, thank you very much. Mark, we're on to you. We have 20 minutes or so left. Is that sufficient time to...
That's plenty great. For the introduction. So, okay. Hi, so I'm Mark Novak. I chair the JRC SIG, so we're the sister SIG for this one. And we deal with basically influencing standards bodies, industry bodies, etc., to create things, and it's kind of a wild card term, to help adoption of confidential computing via guidance, regulations, and we are working with industry bodies to create such guidance and regulations. So right now we are closely collaborating with the Cloud Security Alliance. We are reaching out to NIST, and we are basically hoping to change things like the NIST cybersecurity profile, things like the CSA cloud controls matrix, and there is a charter document that we have that I can share. Or I've already shared it some time ago with the TAC. And what we've been doing for the last several months is working out the what's called governance patterns around attestation. So attestation is the crown jewel, right, of computational computing. I don't need to explain it to this group of people, but we are looking to govern attestation, and governance itself is a term that, unless you've been thinking about it for some time and if give me an answer off the top of your head, you're probably going to get as many answers as we have people in this room. And in the governance charter, we have a definition of what that means. So what we have so far is a document, which I will say two things about it while I still have your attention and it hasn't drifted. Two things I wanted to get out of this. So the document that we have compiled is, for one, not a final shape it will take. So I believe we need to actually rewrite it using what's called a patterns language, which again, I can provide references. It's a fairly well-established industry technique on how to write patterns. I know my employer certainly follows it to some degree of success. And the second thing is, whenever you deal with rules for organizations to follow, out of necessity, these rules have to be very, very technology agnostic. So this is really, really important to internalize. So when we formulate things like, you need to govern your system, it needs to be done in a way that does not recommend or let alone force the use of any particular technology. So wherever possible, we're going to use terms such as protection of data in use, not terms like confidential computing, even to that extent. So let alone recommend a particular attestation solution or anything like that. So now, given of what confidential computing is and how it compares against some of the competitor technologies, it satisfies the letter and the spirit of what regulations are, but it's also sneaky in a way because good luck doing something better than confidential computing if you need to protect your data in use. That's sort of the the back door through which I think such things can be snuck in and not upset anyone. So this is what we need from this group as the very first thing. So we have a document. In fact, let me share it right here. I mentioned it in the TAC August 10th last week. I would like to.
Mark, there's
Yes.
a question from Osama.
Yeah, hi, Osama, what's your question?
Yeah. So a quick question. So when you say that you don't mention confidential computing and you mention techniques, let's say for protection of data in use or something like that, then in what context would that make sense? I mean, for other techniques, would attestation even make sense?
Okay, let me explain. This is a good question. So when
just to clarify, I mean,
no, I do want to clarify. I don't want to clarify
Okay,
how it's going to
sure,
go. So if you look, and by the way, a lot of engineers don't actually deal with regulations, and this is why there is such a big disconnect between the two spaces. And I will even tell you, I'm an engineer myself, and I'm not doing this out of love. It's just that there is no other way to get confidential computing adopted. And I know because I work for a regulated institution. So when you look at something like the cloud controls matrix, so CSA CCM, it's currently in version 4, you will find 3 tabs. There is a tab called control specification. This is as high level as it gets, mentions no technology by name.
Okay.
And then it has like over 100 different rows in that spreadsheet. And again, I have it, I tried sharing something. I can even show you an example of this because I have it loaded in one of my, let me take a look. Why, like last time I tried sharing, it's not sharing the right thing. This is the screen I was hoping to share. Let me try it again. See, it's not showing the right thing.
I see sample attestation flow.
Oh, there. Okay, so you are seeing the right thing. Okay, good. All right. So let's get back to this. So this is our document. This is what I want to show you. Can you see this? This
Yes,
is the
we
cloud.
can.
This is the cloud
The
controls
Sheets
matrix.
doc.
Yeah, the Sheets doc. So this is the CCM loaded in a spreadsheet, and you will see there are 3 tabs here that are interesting. So one is called control specification.
Mark, can you increase the font size slightly?
I can certainly.
Yeah, okay, I guess you can also do that.
Yeah, okay. So these are control specifications. Like I'll just click at one at random. Implement detection measures with proactive indication in case of changes deviating from the established baseline. Like this is very, very high level. But then for any particular row, say I think an interesting row we've been looking at is row 48, which is let's see what's good. Okay, fine. Establish, maintain encryption, key management, risk program, includes provision of risk assessment, risk treatment, risk content monitoring, and feedback. If you go over, there are 2 other interesting tabs in the spreadsheet. One's called implementation guidelines. So control specification, again, the most high-level statement that you can have that just outlines the topic. But then how do I implement it? Well, implementation guidelines would be more, so again, row 48, more detailed, that we will say something more along those lines. So here's an implementation guideline for this control specification. You can read it. You don't have to read it right now. I'm just like, just eyeball it and figure out that it's more detailed. And then there are auditing guidelines. So again, I'll scroll down to 48 and we will take a look for the same control specification. There is this auditing guideline that again explains what it is you're supposed to do as an auditor looking at the thing. So, okay, this is sort of the level at which governance needs to operate. Going back into the attestation governance patterns. Because I'm not, I don't have a lot of time here, we would need to compress this to just sort of down to the bare ask. What I would like to ask of the SIG right now, and then I would love to follow up a couple of weeks from now again, is to give this document a review. So let me give you sort of a roadmap for what we're hoping to do with this. When we started looking at how would we frame and govern attestation patterns, we found that, okay, there is content. Please comment on the content. I know, Simon, you already mentioned a few things. Yogesh mentioned a few things. Osama, mentioned a few things. Or Muhammad, sorry. So I responded to the comments that were received and I made a couple of changes. We would like to make sure that this content is solid. Now, this is not going to be the final version of this document because there is a patterns language. We would like to write it as a patterns language, and we can talk about sort of what the pattern groups are and what the individual patterns are. Again, we're not going to be able to have a substantial discussion on this today. But we found and called out in the document several places where there appears to be perhaps a semantic disconnection or imprecision in terms, or perhaps poor understanding on our part. There could be any number of reasons. Lex is not about pointing fingers, but we found things that we consider somewhat problematic, and we would like to have sort of a discussion with this SIG, so between the GRC SIG and the attestation SIG, on certain things and uses of terminology, and because without this precision, we don't believe we can have make substantial forward progress. So I will give you a few highlights that I believe are sort of important in understanding sort of the general flow and direction of this document. We are looking at the general case, and I'll scroll down to illustrate with a.
Hey, Mark, Muhammad has a question.
Muhammad, yeah, what's your question?
Yeah, so I'm not sure if I am if I get your answer that I had for the previous question. So I'm still a bit lost. So maybe you can clarify, just to clarify my own question. So the protection of data in use, the other technique, for example, homomorphic encryption, right? So
Yes.
multi-party computation, they
Yes.
don't attestation at all. And
Correct.
I see this as attestation is something that's very specific to confidential computing
Yes.
as one specific technique.
I apologize because when I started talking about the tabs in CCM and I didn't complete it to answer your question. So let me do that now. So in the control specification, which is the sort of the first thing you look at, you will have something that's entirely technology agnostic. I doubt we're going to see attestation mentioned there, but we might say in places where CCM says protect data in transit, protect data at rest, we might also want to say protect data in use. Okay, that would be the delta for the control specification. And then when you go into the implementation steps on an as needed basis, you might want to say when protecting data in use with confidential computing. So again, we're not mandating, but we're saying in implementation guideline, if you choose confidential computing in order to protect your data in use, then attestation blah. And similarly, for if you're using attestation to attest your confidential computing workloads under the auditing guidelines, this is how you do that. That's the link. So patterns, the attestation patterns, they go way more detailed. They are not things that you expect to be reflected at CCM, because CCM again is going to remain somewhat high level. But here is sort of the hope to emerge out of this work, that there's going to be a set of patterns which are not libraries, they're not software, they're not reusable in the sense that open source is reusable, but they are reusable ideas. And if an organization is figuring out how to implement, safeguard, audit their confidential computing environments, hopefully these patterns would give them what they need. And hopefully we can use these patterns to influence folks like Verizon, like Microsoft Attestation Service, like the Google Attestation Service, etc., and have a conversation with them and saying the attestation SIG feels like, or perhaps in conjunction with the GRC SIG, we could make this a joint statement of patterns that say these are the ways in which you secure these aspects of your confidential computing environment. And does this work for you? How would a customer using your solution be able to know that certain things are done properly, etc.? And it becomes a way of guiding the industry and collaborating with the industry to make sure that anybody who wants to adopt this technology has a repeatable, proven, blessed by experts way of doing it.
It's also, this is really important, a way into the regulators, because once we have this, we can talk to the regulators and say, look, there is something mature enough, which is considered enough that you can start talking to people and saying, you need to think about adopting this. They can push back, but at least we've got a starting point, right, Nova? Right, Mark?
Yes, absolutely.
Yeah,
it's very important for any regulated institution to once they are being told you got to use this, or once they decide for their own reasons why they want to use this, that they know what it is they're supposed to do in a way that there is an agreement between different sides of like when two businesses collaborate, or where business is responsive to regulators, and there is an auditor that comes in and takes a look at what it is they're supposed to be looking at. They all get informed by these documents. They don't go invent their own things. Otherwise, we respond to over 100 regulators, and if they were all had their bespoke ways of doing things, it's hard enough as it is. But with this, what ends up happening is even we are respond to 100 different regulators, there is still a significant commonality, like very, very significant commonality between them, such that if you do it right, you're going to be making most of them happy. And the difference sometimes is in the details, like, Germany says, keep our data in Germany. Luxembourg says, keep your data in Europe, or whatever, right? So if you don't have these patterns well defined, especially for a new or emerging technology, you are essentially putting your customer out to dry, and it becomes impossible to adopt. So let me show you another picture from here. That's actually very important. So in here, the left-hand side, the contractual obligations, regulatory obligations, internal policy, industry standards, these could be all the different reasons why you might want to adopt confidential computing. And those ones are, so for instance, industry standard might be CSA CCM is an industry standard, but, or that regulatory obligation might come from NIST, the cybersecurity profile. That becomes a regulatory obligation. Now, what we're focusing on is this thing called control objectives. Control objectives are still fairly technology agnostic, but they are technology area specific, if that makes sense. So the control objective will not differ between a Google attestation service and a Microsoft attestation service or Verizon, but it will be written in a way that works for them, but it will have no relevance to confidential, with like homomorphic encryption. And then what we don't do, or except maybe in some implementation steps, we don't really deal with control procedures or implementation steps. Control procedures now can be specific to way more specific than a control objective. An implementation step would be definitely specific to Microsoft Attestation Service or Google Attestation Service. And people can start developing them. They might start vending them as solutions. This is not what we do. We just give them sufficient guidance that when they provide these solutions broadly interoperate, broadly achieve the same goals. And this repeatability is the absolute key to adoption. Like, I cannot stress how important that is. So the first part of this is please review this document. Give us your best advice on, anything that's incorrect, anything that's missing. So we're bringing this to you. We're absolutely not married to any content in this document. The goal is not to have your rubber stamp it. The goal is to basically have an agreement. Yes, the text here is correct. Then what we're going to do is we're going to identify the individual patterns. So far I see like 8 or 9 in there by my count, which again, I don't mind sharing that list of patterns and pattern groups that I have arrived at. And there is a patterns language in which it can be expressed, which is, again, we didn't invent. That's more of an industry standard. And then someone like me or someone else in our SIG would go write these patterns, or maybe someone in the attestation SIG wants to volunteer to contribute patterns. I'm sure this is not an exhaustive list. Like even the presentation from Simon just now, there may be one pattern when you're packaging things one way. There could be another pattern when you're packaging things other ways. It's important for consumers of this technology, for adopters of this technology, auditors of this technology, to basically develop the expertise and know what is what, and not do it independently and hope they got it right, but to do it based on guidance from the experts. Okay. Does what I just said make sense? We have a couple of minutes, so I really don't want to keep talking.
Let me see if I can summarize. You went through a lot very quickly, and most of it's all new material for me. I think the two high-level things I caught. One is you're requesting the folks in this SIG take a read through this doc and provide feedback on what they read based on their experiences.
Yes.
The other, and so I think the goal of this and the details of this are not 100% clear to me, but you want it to go out at some point with a statement that the SIG you're involved in, the governance SIG and this SIG basically have read this, are behind this doc, and then you can talk to regulators and you'll have more oomph. There
is an intermediate step. So first we agree on what's in this document and just have this is basically everything we could think of in terms of what it would take to govern a system from the attestation perspective. Okay. Then it gets, you cannot read this document and build what I envision. That's not yet there. The next thing would be to break this down into individual patterns. Right. And again, I will provide a draft list and we'll finesse it and whatever. Yeah. Right. Then these individual patterns, those are the things that we can publish And then we separately, we will work with the CSA. And again, those are meetings are all public. Anybody can join. We'll work with CSA to change the CCM. We'll work with NIST to go change the cyber risk profile. We'll work with any other regulator out there for privacy enhancing technology. There's many, many of them, and we'll pick them off one by one. But as all that other work is happening, which is very, very high level and, not at this level yet, we jointly with the attestation SIG could polish these individual pattern documents. And what is a pattern? It says describes the context in which there is a problem, describes the actual problem, describes some forces that shape the solution, describes the solution, gives some examples. Again, I'll share some documents with you guys to read to explain like how these patterns work. And once these pattern documents, maybe 9 to 12 of them are published, that becomes the official guidance from the consortium saying if you're developing confidential computing solutions, these are the things that we know will work across all providers, all systems. And whatever your scenario is, you will find this guidance.
Okay, great.
Your
Great, thank
auditor
you.
will know what to do with this guidance, etc.
Yeah.
Unfortunately,
Great.
I have a meeting with CSA literally a minute ago, so I need to jump. I will share with someone on this group, maybe Greg. I will mail you the links because you and I have been talking on Slack to disseminate with the attestation SIG.
Yeah, that sounds good. And I'll share with the broadcast. Are you available 2 weeks from now to?
Yes, I am available 2 weeks from now as well.
All right, because I think we should at least have a 5-10 minute follow up at the beginning of the next meeting to chat through. I think the few remaining.
I will
here.
commit. If you comment on the attestation document, I will respond to your comment. I commit to that.
Cool. All right.
Okay. Thank you all.
Thanks, Mark.
Okay. Bye-bye.
And from a mechanics perspective, next meeting, as far as chairs are concerned, Jim, you and I are the only ones left on the call, I believe. So why don't we follow up offline via email, and we'll figure out the chair for the next meeting and discuss the topics, which at this point are just one, as far as I know, which is Mark briefly discussing this governance document and where he's trying to go with it.
Sure.
Sound reasonable, Jim?
Yeah, sounds good.
Okay, sounds good. Have a good day.